Hi, my name is Marco from Light Object. Today I'm going to show you guys how to do a basic setup on fiber, I mean not fiber, a hybrid metal cutter. And we are going to use the Katana, one of the biggest the metal cutter in our shop. I don't know if you guys know about hybrid system. What a hybrid system is, it is same as a CO2 laser, but with oxygen assist, it can cut metal and it can cut non-metal as well, like MDF, acrylic, bamboo, or leathers. If you look at this system, the major difference for a hybrid system is a special laser head. For metal cutting, we have to keep the distance between the laser tip and the metal. So, and it has to be very accurate. If it misses 0.1 mm, the cutting job could fail. All right. By looking at this laser head, as you can tell, there's a motor built in, and this is the amplifier for the signal detector. And there's a ceramic coil over here. So it detects the metal and it controls the laser, the focus point up and down. But this is used for the metal only. You can use this system for non-metal. When you switch the mode from metal cutting to acrylic or for wood cutting, you have to disable it. Otherwise, the laser head will collide with the bottom. So when you switch from metal cutting mode, you have to non-metal, you have to turn it off first, all right? Okay, for the controller on hybrid system, it's a little bit different than regular CO2 laser. It has to work in conjunction with a height control. This is an extra board in addition to the CO2 laser. And on Katana, we are using a Raider controller card. This is similar to regular CO2 laser DSP controller card, but with hybrid feature built in, all right? Now, if you look at the side of the machine, it is very similar to regular CO2 laser, but with a couple different things. If you look at that closely, there's a 3 different air hose connector. This is an air pump. This is not it's not controlled by the controller card. Actually, it's controlled just by the socket over here. So you plug in the air pump to here. When the system is running, when you enable air, the air pump will kick in. And then next to it, there's a compressor air. Compressor air is when you try to cut MDF, acrylic, and it's not metal, then you use this compressor. And this is controlled by the DSP controller card. And the last one is O2, means the oxygen inside. If you look at that way, all right, I connect a hose to a oxygen tank. So when we are doing the metal cutting, we have to use oxygen to assist the cutting, or it won't work. And then there's another nice feature. There's an air valve control. This one's only control the air from the air pump. It doesn't do anything to the O2 or to the compressor. And on top of over here, there's a auto controls button. This is for metal and non-metal selection. So I'm going to run a demo after this. Okay, let me talk about the Katana a little bit. For most laser machine, you need to be very careful to the laser, the current going through the laser tube. When you driving a laser tube, you could shorten the lifespan of the laser tube, or you could cause the power, the performance drop. So when we set up our laser machine over here, we put a lock, the maximum current that allow to go through the laser tube. And also in most of our machine, there's a current meter built in, like this one. For 80 watt to 180 watt laser tube, we will limit it to either 28 to or 30 MA for the max. But for this one, we put a 220 watt, 240 watt laser tube. So the maximum current could go as much as a 32 milliamp, and is a driving by 250 watt power supply. I'm talking about two laser power supply, not just one. All right. So let's go over here and let me show you the laser tube. Okay. This laser tube looks pretty similar to a regular laser tube, but if you pay a little attention, this is a single tube, but dual cores. What does it mean, dual cores? If you pay attention, or if you look closer to the tube over here, you see that there's a two small tube installed inside of a single tube. So this is just like a two laser tube firing in parallel mode. So combine the beam together. So it come up 220 or 240 max power. And there are two terminal for each end. I mean, there's a two ground and two high voltage side. However, when I said two ground and two high voltage, is not correct. Actually, one of the tube, the ground is actually a folding ground, so it's not just ground. The configuration is a little bit different than a regular CO2 laser tube connection. It's just and we have to provide. We have to special make a power supply in order to drive this laser tube. All right. And one of the good feature about the Katana is, as you may know, when you cut wood or acrylic, you will see a bunch of smoke coming out during the cutting. And I would say 70 to 80% smoke is going to rise up instead of dropping to the bottom. When we operate a laser machine, we have to hook up a couple of things: air assist, then exhaust fan. Because most air, it would drop down. 20% for air may drop to the bottom, and 70 to 80% is going to rise up. With a small footprint CO2 laser, like let me see, like this one. See, this is enclosed system, enclosed laser machine. So when you connect an exhaust fan to the back of the machine, it's pretty easy to drag the air out. However, on this open system, most smoke, it will come up from the top instead of going to the down. So the best way to do the air or the smoke filtering is to build a hook or put it on top. But I found out that there's a pretty unique feature on this Katana. Look at this. There's a hose built on the side, and underneath it, there's a channel, and with 4 or 5 intake hole. So when you cut something, and you find, if you hook up this hose to a exhaust fan, it could drag or suck in all those smoke from the channel underneath it. This is a really good design, very unique feature. All right. Okay, I'm going to fire up the machine and show you guys how to do the calibration for metal. If you look at this, there's an emergency stop over here. You just see. And then this is a laser power. So we can turn off the laser power even with the machine power up. Sometimes we want to do some calibration or some testing without power on, because you never know what could happen. That's why it's for safety. We should turn off the laser power until we are ready to go. Okay. So the system is reloaded. Now I'm going to. Piece of stainless steel. By the way, I took two blades out. There's a reason to do it, and I'm going to show you guys why would I want to do it. This is very important for the first time calibration, and also for calibration. You don't want to use a small piece of metal. You should get at least some metal with size 2 feet by 2 feet. The reason is, if you put if the metal sheet is too small, the sensor may not be sensitive enough to make the calibration, because this is a metal sensor. If this metal piece is too small, it won't work properly. All right. So that's why I'm trying to. I'm putting down a big sheet here. So before we do the calibration, for a hybrid laser machine on this particular model, we use two different kind of laser tip for the hybrid system. One for metal and one for non-metal. This is for metal cutting, and I'm using 1.5, and this is a copper mate. All right. But the one that used for non-metal, let me move it up first. This is a little bit different. This is if you look at those, when I put it together, you can see the difference. The air hose is running about 3 mm and shorter. And this is aluminum, and this is copper. We need copper for metal detection. All right, so I'm going to swap it and put this one back. We need to make sure this is secure tight, because if this one get loose, it won't detect metal properly, and you will get very lousy cutting. Okay. After we swap the laser tip. Now we are ready for doing metal cutting. Calibration. So make sure this one is working. Okay. So there's a button on the side of the machine. We need to enable it. Now we need to enable autofocus. So you press the top right here. All right. Now, if you press the other button, this is an autofocus setting. So it calibrates itself to get a perfect point. For hybrid laser machine, for a hybrid laser machine, the focus is about 1 mm above the metal. So let me try if this is ready. Okay, I press this button. Now pay attention to the laser head. You're going down and touch it, and it will go back. Now it sends properly. And it will move up. It take about 10 seconds to complete. Yeah, it's almost done. The screen will show the calibrating. It will show calibrating. Now it's done. So that means the system is ready to function. So how do we know it's working properly on autofocus? Now there's a button on the control panel, the full stop, the stop here. If I press it, you see that the laser head is going down to the metal with roughly 1 mm in distance between the tip and the laser and the metal sheet. Now if I move this one up, you see that it's a tracing the metal sheet, so it's working properly. And if you touch it by hand, I think there's a protection. See, you touch it, it will lock it up for safety. Now you're going back. Or sometimes you touch it, it will bring the laser head up for protection. All right. Now, let me put it down, put it back. So it will bring the laser head back to the ready position. Remember I mentioned about the blades, that two missing blades here. The reason I did that because sometimes when you try to do metal detection, it may fail, all right? So when it fails, the laser head is going to drop down as much as it could, and it will slam to the metal or to the blades, and I don't want that happen. But if in that case happen, if without the blades, so you can see that the metal over here without support is pretty soft, right? So it won't do a hard collision. Instead, it will be a soft one, so it won't cause too much damage to the laser head. Now, there's another calibration over here. That one is for, I would say, a light version for the day. But this one is more, how to say, a more complete calibration, and it will write into the controller itself. So how to do it? Now, could you zoom in a little bit? Okay. There's a menu here. You press it. There's a setting, calibration, touch set, and alarm information. Let's go down, going down to calibration. And you hit enter. Now pay attention to the laser head. It will move down, and make sure you are ready to press the green to reset if something happened. Now it works pretty good. And it's doing the calibration now. And once it's done, then we save the information to the controller board. Hold on. A couple more seconds. Oh, it's done. It asks you if you want to save it. Yeah, press enter to save it. Now the system is in auto mode stage. When do we need to do it? When you change the laser tip, or it's been a while, like for example, 1 week, 2 weeks, and you may want to recalibrate the system. Because the laser tip, there's so many different kind of laser tip. It could be 1.0, 1.2, 1.5, up to maybe 2.0. So every time when we change the tip, we want to do the calibration because it teaches the system to learn how to detect the metal. All right. But in some circumstance, when the system could not detect the metal, especially, let me show you some kind of metal. This is a kind of stainless steel I think it's 412. with some coating on both sides. If I put this one on the machine, sometimes it fails to detect it. So what could I do? Well, there's a trick I found out myself. Let me do the demonstration over here. So I'm going to lay down on the system and try to duplicate the issue. Okay. Okay. I'm going to demonstrate a piece of metal with some coating on top that caused the sensor failure to detect it. Now, for example, let me do the calibration like what I did before. Now pay attention. The laser head is going to drop off the metal sheet and it will keep going down. And when that happens, we need to press the reset key to avoid the full collision. All right, now I put control. Now pay attention. You see the metal, it will bend down. You see that the metal is keep going down and down. It's very dangerous. So before it collide, I need to hit the reset and bring the laser back to the normal before it cause damage. All right. So in that matter, how do we take care of this kind of metal? Well, there's two options. One, we calibrate the laser, the system with another piece of metal, similar metal without coating, and then we use the parameter from the calibration. Or there's another way. So I'm going to move the laser head up a little bit. And then on the control panel, there's another setting called touch set. So I'm going to try to do manually configure to teach the system. All right. So I choose touch set, press enter, and it will ask me to move the laser head down. Okay. So I'm going to use the remote to do it. Actually. Oh, we have to use the key over here. I'm sorry. So you have to move it all the way down. More. Until the tip touch the metal, which is here. And then we hit enter. And enter again. Now the system record. After that, we hit reset to bring the system back. Now let's try again, see if we detect. So let me move it to the top. And let's do the calibration, regular calibration, and hit enter. And I'm still can't trust it, so I'm ready to press the green button. See, it doesn't detect either. So I have to do again. And I may need to clean the tip a little bit. Let me do again. Alright, so this we do a teach again. Let me do the other way. Let me turn off the autofocus and turn it on. let's do this part again. No, we do learning. Okay, I'm going to use soft touch. Alright. You don't want, I'm sorry, I made a mistake. We don't want to hit reset, but we just use the autofocus sensing on the other side on that button. If you look at those, the system detect the metal and then you bounce back. Now you try to go back to the working position. And how do we know if this is working? Well, we can try press the full stop, see if the laser head can drop down to the surface. All right, so it's ready. So I'm going to press the stop right here. If see that, it keep the distance 1 mm above the metal. If I move this one up, it follow. All right, cool. Then, okay, now I'm going to do using a radar software to pull out a file for testing. So we are using metal cut, double click it, and I'm going to pull out a file that I did before. And so on. Okay. In order for metal cutting, we have to add a leading line that is a normal or standard procedure for wood or acrylic. But for metal, we have to add a leading line. So we are going to select the graphic, the whole graphic, and click the cut property over here and enable and put down, well, depend, usually I will put 5 mm, and angle I like to do actually 90 degree. See that it will cut from the inside because I don't want this piece. This is a cut out piece, so the leading line must be setting from the inside to outside. Same thing for the circle. But for the outside piece, I have to start from the leading line starting from the outside to inside because I don't want to ruin this metal cut. All right, and you can manually change it by using draw feature, and you can do it yourself. All right, so and now I need to change the setting. Before, okay, I would say for this stainless steel 1 mm, I could get as far as 12 mm for now, and with power set it to, let's say, 60 to 65, or actually 55. Let's try 55 to 60. The maximum power set up on this machine is 75. All right, and then we need to enable the punch time. See, when we need to create a punch hole before the leading line, so make sure the beam gone through the metal. So how many punch time? It depends how thick of the metal, and I have set up the punch time to 500 milliseconds, which is a half second. So if I put one here, that means it will be 1 of 500 milliseconds. If I put 2, that would be 2 of 500 milliseconds, which is 1 second. For stainless steel, I like to put 2. And how much power? How much of punch power? Well, I like to get 90% and 100% for peak voltage, and then click OK. And then click the download. And you can put a name or whatever, but I use a default for my testing. Click OK. Duplicate, yeah. Now for our file file upload success, so we are ready to cut. Okay, but before we send it to cut, we have to enable the oxygen. So let me turn on the oxygen first. We use the gauge first. And we turn this one counterclockwise. We got only, how much left? Half bottle left. And then we start to turn clockwise to enable the oxygen. All right, so when I turn it, now you can see the gauge is going up. Well, for stainless steel, I like to try at 600 first. All right, that will be cool. Now we are ready to cut. Okay, now I'm going to move the laser to the position that I want to start the job. Okay, let's say I start from here, then I'll hit the origin. So it will start to cut from that particular position. Hit origin. Before I start it, so I'm going to run the frame. See if it is within the area. So it is good. So I'm ready to go. And before hitting the start, so make sure you wear a goggle, all right? Because you will see some flare, some spark coming out, and keep the distance from the laser head. Okay, ready? Go. Oh, sorry. Oh, my mistake. I need to turn on the laser first. Okay, let's start again. All right. Ready? Go. You see that it paused for 1 second to do the punching. Every time when it started, there's a 1 second delay. So next time, maybe I should put 1 of punching time. That means 500 milliseconds should be good enough. All right, it's done. It's not bad. The top, the surface is pretty smooth. The side, a little bit rough. I mean, compared to a fiber laser, but this is totally acceptable. The bottom, there's some minor snagging, and you can clean it up with a tumbling machine or by using an electrical brush, and you can clean it up. All right, cool. And the next one, I'm going to show you guys how to do acrylic cutting. I mean, it's not metal. It could be plywood or MDF. Okay, in this part video, I'm going to show you how to use a katana to cut acrylic. But before we are doing so, we need to change the laser tip from metal type to non-metal type. All right. So I'm going to move it. This is the metal. Put it on non-metal. And look at that, the air hole is a little bit bigger. This is a 3.0. It's done. And before we do anything, we need to turn off the autofocus. Otherwise, it will slam to the bottom of the bed. So I'm going to turn it off. Once turn it off, I can use the remote control to control the Z movement. Right? So it doesn't go down here. I need to reset. Zero. Because you touch the top, the limit switch, so it showed me an error. So what I can do is just hit the escape key. Now it's back to normal. I can move it. I'm supposed to be able to move it up and down. It was strange. It doesn't go down more. Alright, no problem. In that matter, we just need to reset the machine. Click down here and hit the reset button. See, now it's back to normal. Alright. In order to cut non-metal, the focus point is a little bit different. Instead of 1 mm from the tip to the material, it is running about 4 mm. But when you are cutting very thick acrylic or MDF, say 20 mm or anything over 15 mm, I will go down more. See, you don't want to cut doing cutting with the precise focus point set to the surface. Instead, you want to go down 1 mm to 1.5 mm. So in this part, I'm going to try the cutting on 4.5 mm acrylic. Okay. Excuse me. Okay, I'm going to use the Z, move it down a little bit, roughly 2.5 mm from here to there. Right. It really doesn't matter because the focus length installed on this laser head is 63.5 instead of most popular 150.8. So it has more tolerance on the focus point. What is good about to have a longer focus length? So you will get less curve when you try to cut something thicker. Alright, but with something 4 mm or thinner, 50.8 would be good because the longer the focus length, the more power waste to sustain the longer beam. So don't be surprised if you use 63.5 on a 100-watt tube, it cuts slower than 100 watt with 50.8. Alright, just let you guys know about it. So I'm going to give a try on, let me find you. I don't like, okay, this is about 3 mm. So I'm going to start from here and press the origin. And then before I do the start the cutting, I need to press the frame to make sure this is within the area. Alright. And one thing you guys need to be careful, to be very careful when cutting acrylic because it can catch fire very easy. So in general, when we do acrylic cutting, we want to use a lower power and lower speed and lower air to avoid the burning, and also you will get very good cutting edge. It will be shiny and very clear. But for some folks, if you care about speed more than the quality, then you can go high speed, higher power, and high air. In this matter, I'm going to try 25 mm per second, which is really high for 4.5 acrylic. But when I do it, I need to make sure the control in my hand, because when it catch fire, I'm going to press the start key. This is same as a pause key to pause the system. Let the frame went away before I start over again. All right. So not start over again, to continue. Okay. So it's ready. Let's give it first try. See, you see that it catch fire way away because the smoke from the acrylic is flammable. It's easy to catch fire, but we can just let it burn for a couple seconds. It's totally fine if you have a protection wrap underneath it. It's too much, so I let it go a little bit. So start over again. Or let me increase the airflow a little bit. Let's see how much it cut through. Oh, actually cut through. But you can see that the quality is not very good because we are running high speed. You see that there's a lot of vertical line. But again, if your job doesn't need to have a very high quality on catching on the cutting edge, then this is totally okay. But what if you want to get something very shiny, a very clear, higher quality acrylic cut? Then what I can do is to lower down the speed, the air pressure, and the power. Okay, let me try another example. Okay, in this cut, I dropped the power from 60% to 80% and lower, and the higher power dropped from 65% to 20%. Let's see how it goes, right? And the speed, I'm running at 5 mm per second. It will be slow, but the result will be much better. All right, let's go. As you can see, there's so much fire causing during the cutting. So what I'm going to do is I'm putting some cover on top of the brace, on top of the bed, to try to cover up more opening. So more airflow will be coming from here than from the other side of the bed. So let's see if this way can improve the problem or not. Now let's start over. Let's continue. Still not much. So, finally could do. That's my first cut. Anyway, it's not the best result, but as you can see that there's less vertical line, and plus this acrylic is not a very good quality acrylic, and actually we get quite a large fire to burn it. So, but compared to first one, this is a better. However, if we do set the speed lower from 6 mm to 4 mm, the result will be outstanding. All right. Okay, this is it for the demonstration for the Katana. Then people will ask me, why would I want to buy a hybrid system instead of a fiber laser? Well, the first thing you need to consider is the cost. Fiber lasers is running about 4 to 5 times more expensive than a hybrid system, and fiber laser doesn't do non-metal cutting. So if you don't have the budget, or if for your business, if you have to cut wood, acrylic, and sometimes some simple metal work, then the hybrid system is a good candidate for you. For the quality wise, of course, the fiber laser is much better than a hybrid system. Let me show you a couple piece example that I did before. All right. This is our first sample, right? This is a stainless steel 304. Let me get it. So the cutting edge is pretty good on top and okay on the side, but a little bit rough and a little slacking at the bottom. But look at the other one cut from fiber laser. You see that this is a super shiny with a nitrogen. All right, and it will come up more detail, and you can cut even smaller object than a hybrid system. And this is a mild steel from fiber laser. You see how smooth it is? It's shiny, and it's almost no slacking underneath it, and that makes the difference. But if you are thinking to do large metal work, but not consider doing non-metal, then I would highly recommend to go for a fiber laser. But if you have to do both, then hybrid system is one of the best solution for you. Okay, this is pretty much wrap up for today, and thank you for watching. And if you have any question, email me or call us lightobject.com. All right, thank you.